It is 10 o'clock, so let's get started. We've done most of the theory by now, so the next 2 weeks I'm going to talk about some special topics that I think are important and that students tend to think are important as well, or at least like them. Today I'm going to talk about environmental Kuznets curve, and I'm going to talk about environmental justice. After the break, some of the things that I'm going to say may well upset you, but I'm just the messenger, and these things are upsetting, right? Before the break, it's much more dry. I guess attendance is explained by all the deadlines that you have this week, right? For some reason, we are unable to coordinate amongst ourselves when we set those midterm assessments. So, this is where we are. 2 more lectures left, and then the final lecture will be devoted to exam preparation, right? And today it is growth and the environment, starting with the environmental Kuznets curve. The environmental Kuznets curve is named after the Kuznets curve by Simon Kuznets, who you see here. Kuznets is famous for a number of things, one of which is winning the Nobel Prize for his work on development, another is for inventing gross domestic product. The Kuznets curve is shown here in this particular graph. On the horizontal axis you're looking at income, or rather log income. On the vertical axis you're looking at the Gini coefficient, which is essentially a measure of income distribution. If Gini is 0, then if Gini is 1, then everybody has the same income. If Gini is 0, then one person owns everything. And Kuznets hypothesized, there were not much data at that time, that in the early stages of development, societies are egalitarian, then they go through a period of income redistribution, so that rich people get a very large share of total output, but then when they go richer still, they go back to an egalitarian society. And if you do that cross-sectionally, you see that it is not untrue. It's not quite as simple as Kuznets hypothesized, but that is the original Kuznets curve. Now, the environmental Kuznets curve is shown here at the bottom, so let's blow this up. The idea here is that traditional societies are so poor, mostly agricultural, that they actually put very little pressure on the environment. Then as economies industrialize, environmental pollution increases, but then as they grow further still, pressure on the environment falls again. So that is the basic idea behind the environmental Kuznets curve. This was popularized, I can't say that word, in 2 papers by the 2 gentlemen you see here, Gene Grossman and Alan Kruger, who actually took this theory, this hypothesis, to the data. And in 2 papers, first version published in 1991 and final version published in 1995, they actually looked at, is this true or not? And they came up with a very mixed answer. And here are some of the figures from their paper. What you're looking at here is always on the horizontal axis we're having GDP per capita. We're always looking across countries in the world, so this is cross-sectional evidence. What you're looking at here are sulfur dioxide in cities, smoke in cities, and heavy particles in cities. And only here you see sort of an environmental Kuznets curve type of relationship. You also note there's actually only 6 observations. Then if we move to water pollution, so this is dissolved oxygen, this is biological oxygen demand, this is chemical oxygen demand. This is essentially a measure of how much stuff there is in the river. And this is nitrates. May have said something wrong. And you see again, yeah, sometimes you can see something that looks like a Kuznets curve, like here, somewhere here, but here it looks actually the opposite. It's the wrong way around. We move to feral coliform and total coliform. This is essentially a measure of how much shit there is in the water. Literally, it may be animal, it may be human. Here you see something like an environmental Kuznets curve. Here you see something that is very much not a Kuznets curve, but you also see, well, they only have 6 data points, 7 maybe. I think this is a data point as well. And if we then move to heavy metals, lead, cadmium, arsenic, mercury, nickel. Again, the relationship seems not so obvious. They were brave and they estimated a quadratic relationship with per capita income, so they regressed their environmental indicators on income and income squared. So you have, in theory, this nice parabola that we started off with. And then estimate the turning point, that is peak GDP. At what point does environmental pollution peak? And lo and behold, they find a wide range of results from something like 2,000 for lead all the way up to 12,000 for cadmium. And some of these things are not significant. For lead, for instance, the best guess is 2,000, but then the standard error is 3,000, so they really say it's 2,000 plus or minus 6,000 is the answer. That is not particularly informative. So this was the start of the environmental Kuznets curve, and actually it should have stopped there, right? Because if you recall these graphs, none of them looked like the hypothesis that they started off with, and it's actually all fairly weak evidence. But it was published in a very prestigious journal, so it spawned a large literature, and a literature that is still growing. And what people have tried is, let's look at other indicators of environmental quality, and definitely monitoring of the environment, not just the ability to make graphs has improved since 1995, but also our ability to monitor the environment has very substantially improved, and a lot of people used alternative indicators to what Grossman and Kruger used. People have focused on a different set of countries, or within countries at different sectors, sometimes sectors across countries. People have focused at different time periods. Definitely we have 25, almost 30 years more, 30 years worth more of data than they had originally. And also people have been pushing this deeper into the past. Obviously, people have tried different ways of specifying the relationship between them, different control variables, different functional forms, and of course, the econometricians, when they got their hands on this, have tried all sorts of different estimators. But by and large, the empirical literature is as confused now as it was at the very start. That is, sometimes you find something that looks like an environmental Kuznets curve, and sometimes you don't. And even if you find one, then if you redo it with a different estimator or a different set of countries or a different environmental indicator, then what appeared to be a robust relationship in the first paper turns out to be fragile in the next paper. Which of course then gives rise to yet another PhD student saying, well, I can do this as well, and I'm going to write a paper trying to reconcile those conflicting estimates, just adding to the confusion. I list here two, actually by now fairly old review papers, one by David Stern, who wrote about the rise and fall of the environmental Kuznets curve, pun intended, and another by Matteo Galliotti, who titled his paper Desperately Seeking the Environmental Kuznets Curve. Matteo is a big fan of Madonna, which is why that paper is titled that way. And that, I mean, these reviews are by now 15 years old, and you can read from the title, guess from the title, that there is no robust evidence for or against an environmental Kuznets curve. It's just all very, very confused. Now, 15 years have passed since these reviews, and hundreds, at least, hundreds, maybe 1,000 or more papers have been published on the subject, and the confusion is still the same as in the original Grossman-Kruger paper. Now, if you think a little bit harder about this, this is entirely unsurprising. What is the effect of economic growth on the environment? Well, there are essentially 5 things going on, and only 2 of them have an unambiguous effect, and actually have the opposite effect. First thing is that if the economy grows, it is bigger, and therefore we use more stuff, we use more resources, that is some pressure on the environment, we generate more waste, and we generate more emissions, right? Just by the scale of economic activity, if that goes up, then there must be greater pressure on the environment. So this is unambiguously a negative effect on the environment. And that sort of may explain sort of the very first phase of the environmental Kuznets curve, where as the economy grows, pressure on the environment goes up. Then, as an economy develops, also the composition of the economy changes. Traditionally, we were hunter-gatherers, then we became agriculturalists, then we moved to industry, and now we're working mostly in services. And you could make the argument that definitely heavy industry is dirtier than agriculture. And you could definitely make the argument that in general services are cleaner than industry. But that holds only sort of in the broadest terms. One of the things that people are currently worried about is the enormous demand for electricity generated by data centers around the world. Because more and more of our computing is moving into the cloud. Not just computing, but also mining for bitcoins and those sort of things. That is enormously power hungry. And that is actually one of the fastest growing demands for electricity at the moment. And that is a dirty services sector, right? So it's not just that, it's not necessarily that services are clean. Also, as people are more and more into services, the demand for travel also increases with that, as people would like to meet face to face. So it's not at all straightforward. Similarly, agriculture, definitely intensive agriculture, can be actually quite dirty, right? So the composition of the economy actually can work different ways in different directions, put different pressures on the environment depending on the time and the place and the exact nature of the activities that you're doing. Another thing that happens with economic development is that technology progresses, which often is used to save on resource use, because resources are expensive. So if you can bring a new gadget on the market that does the same thing but with less input, then you have a good selling point, right? So technology tends to improve the environmental pressure of any given technology. But at the same time, technology brings all sorts of new stuff on the market. Some of it is clean and innocent, some of it is quite dirty. For instance, one of the things that we're currently expanding very, very rapidly are solar panels. Now, solar panels are great for making electricity, but they're full of nasty chemicals. The same is true for batteries. Batteries are full of nasty chemicals, heavy metals and everything. And this is generating, or will in the near future, generate a huge chemical waste problem. At the moment, most solar panels are still young enough to be on people's roofs, but within a decade or so, they will have to be replaced, and old solar panels are extremely dirty. They're chemical waste. They need to be handled very, very carefully. So technology also, I mean, yeah, solar panels are good for CO2 emissions, or rather they're bad for CO2 emissions. They reduce CO2 emissions. So they're good for the climate, but they're bad for chemical waste, right? Earlier I talked about how we solved the eutrophication problem through technology, but introduced pseudo-hormones into our detergents, right? So technology can work either way and may work in opposite directions if you look at different environmental problems. The fourth thing that happens as people grow richer is that they sort of like move up higher on the Maslow hierarchy or pyramid of demands and desires. And that is, if you are richer, you can afford to care about the environment, and you demand a cleaner environment because you simply have the time and money to start worrying about these things. That is unambiguously positive for the environment, right? This unambiguously drives us towards a cleaner environment as we grow richer. And then the final thing that changes is that at different stages of development, governance changes. And one of the things that happens as countries grow richer is that governments get more competent, that governments simply, they can collect more money in taxation, they can hire better civil servants and project engineers who can do things. So delivery of environmental protection improves as countries grow richer, simply because the government becomes more competent. But typically also, if countries grow richer, they become more democratic and take longer to decide. I was looking at the latest numbers on sulfur emissions worldwide. I don't have that graph with me, but it is in the book. I think it was between 2014 and 2020. China managed to cut its sulfur emissions by 90%, 90, which no democratic country can do, right? This is really heavy-handed intervention in industry that only autocratic countries can do, right? So that you may say, well, a very poor country, the Central African Republic, could never do this because it doesn't have it has a very authoritarian government, but not a competent and capable government. China is authoritarian and competent and capable. But the sort of things that you need to do, like ride roughshod over people's property rights and sort of shut people up by threatening to throw them in jail or worse. That is something that democratic countries like the United Kingdom simply cannot do, right? So also governments cut sort of two ways, and you just think a little bit deeper about this. There's actually no reason whatsoever to assume that richer means cleaner, or there is this very nice sort of curve. One thing that does seem to emerge from this literature is that those things that are directly harmful to human health, like stuff that kills you within days or weeks, that is the sort of thing that we really clean up as we grow richer. But other environmental problems, definitely the things that we care about most now, such as plastics or climate change or biodiversity, that doesn't seem to hold at all. Now, international trade complicates all these things, right? I gave you sort of like these 5 reasons. If we then add international trade to the mix, things actually become more complicated still. And the reason is manifold again. First, international trade stimulates economic growth, right? That just Ricardo, Hexerolene, and so on and so forth. So the scale effect is one thing. International trade moves technologies around. Foreign direct investment moves technology around. It's not just that you invest in things, but you also typically bring knowledge. That can cut both ways. You can bring new polluting stuff elsewhere. I'll show an example of that. But you can also say, well, we're bringing our environmental standards to the countries in which we invest. And if a British company invests somewhere in a factory somewhere, say in Africa or in Asia, then you can say, well, they have to adhere to the local standards, and they are typically lower than they are in the UK. But they also have to justify their behavior to their home country and the people who buy their stuff in the home country and the people who invest in them. And that is a reason for these multinationals, even though they are in a faraway country with much laxer environmental standards, that is still a reason for them to sort of like stick closer to European standards of environmental care, right? It's not just that they bring the know-how and the capital to do this, but they also have a reason to do this, right? Similarly, if you are a multinational, or in the sense that you're selling your products everywhere, then you have to choose, do I differentiate my products for every different market in which I'm selling? And do I sell products with a lower environmental standard in countries that have lower environmental standards? Or do I make a single product that I can sell in any market, that is, I produce it to the highest possible standard? Now, it is cheaper to design a product once. It is easier to train your managers who manage the production process only once and give them a standard set of training. So it is actually cheaper to produce a single product than multiple products for multiple markets. And of course, if you have a single product that you can sell everywhere, you're sort of heads against fluctuations in demand in the different markets in which you're trying to sell things. So it is actually often a very good idea to produce to the highest possible standard. And we've definitely seen that, particularly in the United States, where a lot of environmental standards are set by the states. And if you want to sell a car in the United States, then your best bet is to sell a car that can be sold in California with very strict environmental standards, because if you can sell it in California, you can sell it across the United States. And even if North Dakota doesn't impose strict standards on their cars, you would still want to be able to sell your car also in California. So essentially everywhere in the United States, the Californian standards are enforced, or at least implicitly followed, because that simply makes business sense. But again, it does not necessarily have to be this way, because you could also, not for the environmental standards on products, but for the environmental standards on production, you could say, I'm going to go for the country where production is cheapest, and if environmental standards are a large cost of my production process, then I'm going to find the country with the lowest standards. And you may even take that a step further and say, I'm going to go to the country where I can most easily convince politicians to lower the standards, right? And we definitely seen things happening like this. And that is what is shown in this graph. I said I wouldn't talk much about climate, but this is simply best documented for CO2. So we're looking at 4 countries, obviously the UK, India, China, and the United States. In the blue, you're looking at emissions that happen roughly within the country. Then in red, you're looking at the emissions that originate from consumption within the country. So if you focus on the UK, then what you see that our territorial emissions have fallen from 1990 to 2022, from 6,000 to 3,000. So we roughly halved our emissions of CO2 over this period, which is quite impressive. But that is the stuff that is made in the UK. If you look at the stuff that is bought in the UK, then emissions are higher, and emission reduction has not nearly been as impressive as it is for territorial emissions. And the reason for that is very simple. We buy more and more stuff from China, we buy more and more stuff from India. And in India and China you see the opposite, that their emissions from stuff that is made in China is much larger, it's somewhat larger than the emissions from stuff that is bought in China. And the reason for this is very simple, that a lot of heavy industry has moved from Europe to Asia. And with that, the emissions that come from that heavy industry, right? For the US, you see a similar but less pronounced pattern than the UK, because the United States is a less open economy by virtue of its size, right? So this is not just offshoring of production that you are well familiar with, but also offshoring of the emissions associated with that production, right? So this is perhaps a negative thing about international trade. CO2 is of course a global problem, so it doesn't matter whether the emissions come from the UK or from China, the climate doesn't care, but of course with this heavy industry we're also offshoring sulfur emissions, we're offshoring particulate emissions and so on and so forth. It's a local or continental environmental problems, and there of course we're shipping our environmental problems and the associated health problems to places like China and India, right? And that is clearly to their detriment and to our advantage, right? What does this do to the environmental Kuznets curve? Here is one example. I forget which paper this is from. So here they estimate the standard environmental Kuznets curve, right? So you have a y and a y squared, so you regress biological oxygen demand, which is essentially I won't get into what that is, but it is a measure of water quality, let's put it that way. And which has this very nice environmental Kuznets curve type of thing. Actually, it's the wrong, no, it has It is not an environmental Kuznets curve type of thing, because it is this shape, right? So it's bad when you're very poor, then when you get richer it improves, and then it starts getting worse again as you grow richer. That is what these coefficients mean, which is the exact opposite of the environmental Kuznets curve. But then when they start controlling for trade, the relationship with income just completely disappears. Just nothing is significant anymore. Then they re-estimated the model to make it significant again, but changed the specification, of course, and then you see that the numbers are completely and totally different. So yeah, trade complicates an empirical relationship that was already fairly shaky. Same here. What we're looking at on the horizontal axis is income per capita. Here we're looking at production emissions. We're looking at a bunch of cities in China, in the UK, and the United States. And you see there's some sort of relationship with income. Then if you plot production emissions against consumption emissions, you see, well, no surprise, there's no one-on-one relationship between the two. So when you then redraw this graph, replacing production emissions, so things that happen within your city, by stuff that is bought within the city, you see that the relationship is very, very different, actually becomes more regular. If you then plot the two against each other, you see an environmental Kuznets curve develop between your the difference between your production and your consumption emissions. So trade just makes things very, very, very much more complicated, right? The environmental Kuznets curve also holds over time. This is a result, very long-term result for the United States. This actually looks at the evolution of emissions, CO2 emissions from all fossil fuel combustion in the United States for the last, I think it was 130 years, maybe a little bit longer, because actually income starts at around 2000, so this goes back to the middle of the 19th century, I would think. And if you look at CO2 intensity, so that is essentially how much CO2 you need per dollar value added, you see something like an environmental Kuznets curve. It goes up and then it comes down again. That is mostly to do, as you see here, with a shift from coal to other fossil fuels, first oil and later gas. But that the environmental Kuznets curve in emission intensity in green does not really translate into an environmental Kuznets curve in CO2 per capita, right? Because if you then add economic growth to the picture, then this declining slope is actually exactly offset by increased income. And what you see if you look at emissions per capita, they grow very rapidly to this turning point, and then they essentially become stable, maybe inch upward a little bit. Then of course, if you multiply this by the growing population size of the United States, you see that CO2 emissions in the United States are increasing and increasing and increasing and increasing. And it's only the last couple of years since the Biden election that things really start to improve in terms of falling CO2 emissions in the United States. That is really something of very, very recent times that is not in this particular graph. Now, that is the empirical evidence for the environmental Kuznets curve, or rather the lack of empirical evidence for an environmental Kuznets curve. This is a very ironic story, also a very sad story. I started with Grossman-Kruger, right? Now, Kruger is a sad story. Alan Kruger would have won the Nobel Prize had he lived long enough. He is a co-author of David Card and Josh Angrist, and he would have won the Nobel Prize, not last one, but the one before that, with them had he lived. And the reason that these guys won the Nobel Prize is for the so-called credibility revolution, that we moved away from associations, from sort of like we're estimating a relationship and we think it is causal, but we cannot prove it is causal, to the sort of empirical analysis, sort of statistical analysis that is much more common in medicine and in the natural sciences, where the statistical analysis, where the correlation is actually causation, right? And Kruger was at the forefront of this revolution in economics. He used to joke that his most cited paper is actually in environmental economics and not in health or education or in labor, where he did most of his work. And I used to joke back that, yes, and your most famous paper is an association, not a causal relationship. And that is essentially what all this empirical evidence is. They're just correlations. There's no causation. So in order to understand that, I'm going to take one particular example to tell you what is the causal chain. And the example that I'm going to pick is cycling. This is a map of Europe of all cycle paths. And what you see is that these are heavily concentrated in the low countries, right? There is simply much more cycling infrastructure there than anywhere else. And a lot of people sort of seem to think, but this is because they are Dutch, or this is because they are Danish and it's in their genes to cycle. That is what a lot of sort of Anglo-Saxon English-speaking people say about cycling in the Netherlands and Denmark, that it's somehow a cultural thing or sometimes even a genetic thing, which is complete nonsense. These are two streets in Amsterdam taken at 3 points in time. This is the Eerste van de Hekstraat, this is the Tolstraat, named after a cousin of mine. In the 1950s, streets were for people. 1970s, streets were for cars. Nowadays, streets are for people. I mean, the pictures do not exactly line up, but they are of the same spot, same time of day, and so on and so forth. So we clearly see a Kuznets curve here, right? Rich, richer, richest, few cars, lots of cars, few cars, right? So in terms of the environment, this looks like a Kuznets curve. Now, how did this happen, right? Was this because Dutch people grew richer still, or were other factors at play? Well, the most important factor that was at play is shown in this graph. These are the number of people for each year dying on the streets. And they're split up between people who are pedestrians, people are cyclists, and then people in cars, right? And what you see is that here also there is a turning point around 1972. And particularly pedestrians and cyclists show a decline in the number of accidents, as well as the people on mopeds. That's the blue that you see in here. This is the same picture, but now not by mode of transport, but by age. The youngest are here at the bottom, the oldest are at the top. And you see also here that there is a turning point around 1972, that before that more and more children were killed each year by cars, and that changed in the early 70s. It was not because people grew richer. This was because essentially, this happened more and more frequently. And in 1972, the son of a very prominent journalist was killed in a road accident. I think the son was 7 or 8 at the time. And he used all his powers of persuasion to start this movement. For those of you who don't speak Dutch, this means stop child murder. That's what these words mean, right? And that sort of led to an enormous pressure on the government to actually do something. You see that here on the left-hand side, this is what Amsterdam used to look like, a reminder. Protests here. This is the Rijksmuseum, right? You have been to, may have been to. Massive protests, people pretending to be killed. You see blockages of roads by angry people, and the same here, right? And this is what really happened. People were fed up with putting their children in danger every morning. And that is what, it has nothing to do with growing richer, it has everything to do with sufficient number of people, a sufficient number of influential people, getting sufficiently angry with the powers that be and say, stop it, and stop it now, right? Well, this is roughly what happened. There's more to the story. One of the things that happened was that Rutger Hauer, who you may know from Blade Runner, before he was a Hollywood star, he was a big movie star in the Netherlands. He made cycling cool by some of the things that he did in I don't know what this is. Some of the things that he did in some of his movies. Another thing that happened was that actually as part of this movement of people getting fed up with what the government was doing, around this time the Netherlands shifted from this sort of patriarchal type of representative democracy, where you elect a couple of toughs to sit in parliament for you, and they treat you with the same disdain that toughs have always done, to a much more direct democracy, where local people had a lot greater say in how the country, and definitely local government, was run. All that came together, and that is what drove the transition away from car-dominated cities to bicycle-dominated cities. So environmental cleanup requires policy intervention, right? It doesn't happen because you grow richer. It happens because you get fed up with the environmental pollution and you intervene, right? And that is very important to keep in mind, that the environmental Kuznets curve doesn't say we're going to solve our environmental problems simply by stimulating economic growth. No, that is not what this literature says. Confused as the empirical evidence may be, this cannot be the conclusion that you draw. This is a very natural point for me to break. We're going to talk a little bit about environmental Kuznets curve after break. We're going to look at it within countries, and then I'm going to talk about environmental justice, and I definitely need 50 minutes or so for that. Before the break, I talked about the relationship between economic growth and the environment, and there was some suggestion there that there's a relationship. And if this holds between countries or over time, then you could reasonably assume that it would also hold within countries, that you could see some sort of relationship there, which is sort of a natural wedge into the main topic for the second half of today, and that is environmental justice. This is a result by Matt Kahn, who you see at the bottom there. And what he looked at was CO2 emissions again, but but now as a function of household income, and this is in the United States, and you see a clear relationship, but it is a U rather than the inverted U that we expect in environmental Kuznets. And the reason for this is fairly straightforward. Poorer people, to your very left, drive dirty cars, old and dirty cars. And then as you look at richer people, they actually drive cleaner cars. As an additional explanation for this, all poorer people also tend to live pretty far away from their work, so they have longer commutes, and that is because houses are cheaper where there's not that much work. So that explains why they emit more. But then if you look at the richest segments of society, you actually see that emissions go up again, and that is these people drive newer and more efficient cars, but they also drive much bigger cars. And again, they start to drive more because they take more holidays and so on and so forth. But you see a clear relationship here between income and CO2 emissions. This relationship is of course very specific to the United States, because if you would do the same for the United Kingdom, then what you would see is that poor people don't have cars, right? They take the bus or the metro or something like that. So that relationship would look very, very different. And it's not just income. This is for results for Ireland. And we're looking not at carbon dioxide, but we're looking at carbon monoxide. So this is the stuff that is directly toxic and also does all sorts of environmental harm. You're looking at two types of emissions here. One is the direct emissions. So this is the stuff that you do in your house. And if it comes to carbon monoxide, this is your heating system, this is your lawnmower, that sort of stuff. And then in the light blue, you're looking at things that are emitted because of the stuff that you buy, right? Here we're looking at income, and you see a negative relationship for the direct emissions, and that is carbon monoxide mostly comes out of poorly maintained machinery and old machinery, and you find that in poor people's houses. Whereas the indirect emissions actually show the opposite relationship, and that is because rich people buy more stuff, right? And therefore also emit more things indirectly. The lawnmowers you see here, rural versus urban. You find more lawnmowers in the countryside than in the city, and that explains this difference here. There's a relationship with the size of the household as well, and the composition of the household that is shown here. Size of the household is again follows fairly easily, and that has to do with economies of scale within the household. If you live on your own, you heat your apartment. If you live with somebody else and the apartment isn't much bigger, you use more energy because you live in a slightly bigger place, but per person you actually have much less space to heat, right? So there's actually economies of scale in energy use, and therefore, because carbon monoxide is so tightly tied to energy use, also in carbon monoxide emissions per person per year, right? So that relationship can be understood, same for household composition. This one is, you may wonder, why do you put this up for Ireland? The reason that I put this up for Ireland is because we only have evidence for this for Ireland, and this is the number of disabled people in the household. Again, you see a very strong relationship with indirect emissions, which is because severely disabled people tend to be very poor because they can't work, and if you have more disabled people in the household, it becomes particularly deprived. And you also see somewhat of a relationship with direct emissions, and that is because if you are disabled, you tend to spend more time at home, and therefore you heat your house more frequently than people who are out for work. So all these relationships pop up, not just for carbon monoxide. I can do this for 36 or so environmental pollutants. I won't bore you with this, but there are clear relationships with things such as income, where you live, the type of household that you live in, and so on and so forth. So the pressure on the environment is different for different types of people, right? Different socioeconomic groups. May also be very different for age groups. This is the United States, the year 2015, and what is measured here is lead in blood. And what you see is, so this from left to right, we're increasing in age, but it is actually the exposure during childhood that is measured. So from right to left, we're looking back in time, right? These were people that were born in, that was at the end of World War II, right? And these are people who are now entering secondary school, right? That is what we're looking at. And you see a very clear pattern here. So this is for this age group, the number of people with very high lead concentrations, lower still, lowest, right? That is how you should read this. You see fairly low exposure to lead for the very old people, lower still for the very young people, and then you see this spike in lead in between. This is essentially, we're looking back in time, this is essentially the gasoline economy in the United States. These people, there were actually very few cars on the road still. Then you see more and more cars on the road, and therefore a greater exposure to lead. And then we started worrying about air pollution, and then we sort of said cars must have a catalytic converter to take out the NOx and the particulates and so on and so forth. Now you can't run a catalytic converter if you have lead in your petrol, so we also took out the lead from the petrol without actually thinking about the lead as an environmental problem. And what you see here is the increased penetration of unleaded gasoline and unleaded diesel, right? So that explains this pattern. Later, people actually realized that lead is pretty bad for you. It hurts cognition. So this generation, your parents really were exposed to a lot of lead and therefore are not that clever. Also, lead leads to increased aggression in people. And some people say, well, these are the people that elected Trump, right? It's not proven that there's an environmental cause for this, but it's not disproven either. So there are just clear patterns within society about differential exposure to environmental problems around society, right? Now, there is more to this. There's much more to this. What you're looking at here is the cleanup of the energy sector in the United States. We're looking over time. We start in 1981, we end in 2016. This was a paper that published a few years ago, and we're looking at the concentration of fine particulate matter. PM2.5 is little dust particles with that are as small as 2.5 micrometers. Very tiny. I think we talked about this before during one of the seminars. To remind you, so this is a physical problem. We're just talking about the size of these particles. It can be anything, kind of very different chemical composition, but we're just talking about physical problems. PM2.5 is so small that it just can run through walls because there's holes in the wall, very tiny compared to you, but fairly large if you're as small as PM2.5. So this is not outdoor pollution, it just runs through walls, and it affects people indoors as well. Has all sorts of health issues, also has direct effects on cognition again. Whereas lead sort of is a chronic effect on cognition. If as a child you were exposed to a lot of lead, you will be dumb forever. If you are temporarily exposed to high PM2.5 concentrations, then you will be dumb for a few hours, right? And it has been shown that this affects the decisions that referees make during baseball matches or umpires during tennis matches. It has been shown that it affects the behavior of judges in courtrooms. It has been shown to affect the decisions that traders make when they're trading on the stock market, and it has been shown to affect students when they're sitting for their exam. So this is not stuff that you want around. Unfortunately, it has been falling over time as we cleaned up the energy sector, moved to better technology. This is the pattern for the US as a whole, but there is a very clear spatial pattern to this as well. You see concentrations falling in the old Rust Belt as economic activity shifted south, and you see an increase in concentrations relative in the southern parts of the United States. Now, for those of you who are familiar with my voice is not going to hold. For those of you who are familiar with the geography of the United States, this is where the white people live, this is where the black people live, right? And that is what I'm going to talk about next. So this picture is the average for the United States. Here in blue, we're looking at the average concentration for the white population, non-Hispanic white population, and in red you're looking at the African Americans. And both are going down in absolute terms, so that is a good thing. But you also see a substantial and persistent gap between different ethnicities in the United States. Now, you may say, well, this is just household composition and those sort of things. So this is the graph that you were looking at previously. Here, the authors control for household characteristics, such as income and education and anything else they could find, AIDS and what have you. Here, they also control for neighborhood characteristics, because the physical environment also matters in how much PM2.5 there is, because winds blow in different directions or mountains may get in the way and that sort of stuff. So you also need to control for the physical environment. And they did that here. And what you see is that the gap persists between black and white. And this is a confidence interval. It is actually a statistically significant difference. And actually here the red is the gap without controlling for neighborhoods and household characteristics. The blue is the gap controlling for that, and you see how actually all that statistical sophistication did not really change the conclusion. And this is an important thing to document, right? This is what is known in the literature as environmental justice, that environmental pollution falls differently on different people because of who they are and what they are. not because of what they do, but because of the color of their skin or something like that. And that, I hope you agree, is unacceptable. This is another example. We're looking at Houston. Two maps of Houston. In the top map, the sort of the red colored areas is where waste is processed, either as landfill or that's probably here, or incinerated or accumulated or something like that. At the bottom, you're looking at a map of where do the minorities in Houston live. And you don't need fancy statistical evidence for this to see that there's a clear correlation, right? The waste facilities are located where the minorities are. This is Richmond. This is a fairly ingenious study. Where to start? Shall we just start at the top? In the 1930s, the local authorities were sort of like waking up to industrial policy and sort of said, we must do something. This was a period of the Great Recession. This was when Keynesianism was just started, and United States authorities, in this case it's more local authorities, city authorities, started waking up to the idea that the government must intervene in some way in the economy. And what they did was they split the city up into different areas, A, B, C, and D, where A was businesses, you should invest here because this is a very promising area, and D was don't go here, don't invest in this particular area. And this is known as redlining in American parlance. The red areas were sort of like deemed not worthy by the city authorities. This was done in the 1930s. And this is the map that they drew. The temperature, or the map that you see here, is the temperature in Houston on the same scale. And the this is the cooler areas. Red is sort of like slightly warmer, and the yellow is that you see here are the hottest places. Microclimates really greatly differ over short distances because they respond to the type of buildings that you have, how many trees there are, and so on and so forth, the building materials that are used. And temperatures can really vary quite a bit over very short distances, and that is what you see here. The scale of this map, you can't read this, it actually runs from 17 to 37 degrees Celsius. So within Richmond you actually see a 20-degree difference from the very coolest area, this is actually a lake here, to the hottest area, right? Areas. This map here, right, shows the polygons, the green areas, the blue areas, the yellow areas, the red areas. Here is the average temperature drawn in the red areas versus the green areas. And you see a very clear difference between those areas. Here we're looking at tree cover. You actually see the opposite, that most of the trees are in the green areas and very little are in the red areas. And here we're looking at the impervious surface, and you can see the difference there very clearly between the green areas and the red areas, and the blue and the yellow is somewhere in between. Impervious surface is important because that essentially tells you if it rains heavily, how much of the rain is soaked up by the ground and how much of the rain actually is runoff and causes local flooding. Right, so the flooding risks are concentrated in the red areas. And of course the heat waves are also concentrated in the red areas. So within the city you see very clear differences between different parts of Richmond. Isn't that big actually? Of a mid-size city. Now, I think Will knows the answer. How did they draw these lines? What was considered an investment-worthy part of Richmond and what was considered let's let it rot part of Richmond? 1930s, they did not have a lot of statistical information to go on. So essentially the people who made this decision traveled around and said, well, this is where the black people live, this is where the white people live, and that is how these areas were drawn. So this was blatant racial discrimination in the starkest terms, right? That we invest where the white people are, we let the black neighborhoods go to rot. So it's a decision that was made in the 1930s, and we can still see the other maps are not from the 1930s but from 2015 or so. We can still see the implications. And actually, if you look at where do the ethnic minorities in the United States live, or in Richmond live at the moment, it is still in the areas that were originally redlined. And that means that these people are exposed to greater floods and exposed to greater heat waves than their white neighbors, right? Decision made, what is it, 85 years ago, still has these implications, right? And this is known in the United States as environmental justice, right? Pressure on the environment is different for different socioeconomic goods. Environmental hazards tend to be sited near the poor and deprived. The poor and deprived are often people of color, and you get racial discrimination in environmental pressures. There is actually a vicious circle here. If you recall, when we talked about hedonic pricing, what we said was that in beautiful environments, house prices are higher. And we use that as a measure, and actually many of you are writing this in the essay at the moment, we use that as a measure for the demand for environmental quality and for the value of environmental quality. But there's a flip side to that, and that is that in dirty environments, house prices are lower, and if you are short of cash and you need a place to live, that is where you'll end up, right? So you have this vicious circle that dirty places attract poorer people. If there's lots of poor people in your neighborhood, actually it's a very rough neighborhood and you would not want to live there, so house prices go down further. No, I should indeed do this part of the story now. And there's another part to this vicious circle, and that is if you are the city authority and you say, well, I need to put an incinerator for household waste somewhere, where do I put it? You can put it in a rich neighborhood, but people in rich neighborhoods are typically well connected. They know journalists, they know politicians, they may actually donate to your re-election campaign, and you don't want to upset them, right? So that is actually a bad idea to put a waste incinerator near those people. They know how to write letters to the newspapers. They know how to organize locally to make a big stink out of your plans, right? If you site it in a poor neighborhood, people have less education, don't really have as much experience in manipulating the planning process, and so on and so forth, have less political influence. So that is a much easier decision to make for a local politician than putting this dirty facility in a rich neighborhood, right? So that is why you see, and I should have said it at this particular point, that is why you see so much of the dirty infrastructure in minority neighborhoods. Because this is the rational choice for the local planners, right? That of course then further suppresses house prices and attracts more poor people into this neighborhood, right? So you see this very clear separation of rich and poor. It sort of like stays over time, and also, yeah, all the dirty stuff is where the poor people are. This has been documented time and time again. There's also recent work where it's actually not explicit decisions by planners that do this, but it has to do with the direction of the wind and the direction of industrial facilities. And you see that downwind of the heavy industry is where the poor people live, upwind is where the rich people live, right? And that is a natural thing because the wind tends to blow in a particular direction because of the rotation of the earth, right? So this is what is happening. Now, the examples that I gave you were all for the United States. In the book, there's also examples for the United Kingdom. Same things happen here. Political story is slightly different here than on the other side of the Atlantic. In the UK, it's more about class than about race. But we see the same phenomena happening here. If there's also increasing evidence for places such as India, where again it's not race, it's not class, but it's caste actually, where you see that in lower caste areas is where the dirty facilities are sited, right? So there's increasing evidence from around the world that this is not a US phenomenon. The next example I'm going to give is actually from the UK. It's from London. Now the fact that environmental pressure on the poor is greater than on the rich then of course immediately implies that environmental policy actually is particularly beneficial for poor people, right? So this is a map of London. On the left hand side you're looking at concentrations of PM10. I can't read it, but I'm pretty sure that this is the particulate matter map, PM10. This is bigger than the PM2.5, 4 times as big. This is the stuff that stays outside, it cannot penetrate the walls, right? So this is outdoor pollution. What you may think this is a map of the road network in London, and you would be fairly close because most PM10 actually comes from transport, right? That is why you recognize the roads in London. Red is bad, blue is much cleaner, right? On the same scale, on the right hand side, you're looking at the deprivation score. So this is a mixture of income and consumption patterns and so on and so forth. And the redder the place, the poorer it is, right? So that is what these two maps are. Now, I haven't got a clue what this map is. Okay, this is the difference. I should just have started reading the first two words, right, rather than jump the caption and try to figure out from the map. At the top map, you're looking at NO2, and this is again PM10. Now you're not looking at the concentration, but you're looking at the projected change in concentration as a result from the introduction of the congestion zone. This is not the stuff that Sadiq Khan at the moment is in political trouble over. This is the very first incarnation of introducing this ultra low emission zone, right? ULEZ. This is the very first introduction of this. And you see very pronounced differences in spatial pattern of the reduction in NO2, nitrogen dioxide, and PM10, right? And you can then map this difference onto the map of deprivation, and then you find this particular map, this particular result. So the further you go to the right, the poorer you are. In blue, you're looking at the change, the expected change in exposure to PM10, particulate matter, and in orange, you're looking at the projected change in difference of the exposure to not N2O, but NO2, right? It's not nitrous oxide, it's nitrogen dioxide. I say, well, so what, right? In this map here, this graph here, you're looking at the projected years of life gained. So this is essentially the avoidance of premature death. Most of it comes from NO2, not N2O. A little bit comes from PM10. And you see that in the wealthiest areas, that is around 40 years of life added. In the poorest areas, that goes up to 65. So this follows immediately from the air was dirty, and the air was particularly dirty in poor neighborhoods. And the reason for that is that road noise is bad for the price of your house. So people who live near roads, houses that are near roads tend to be cheaper, and that means that people who are poorer tend to live closer to roads, right? That follows. And similarly, if you're planning a new highway, then it's easier to lead it through a poor neighborhood than through a rich neighborhood, right? So it's the same siting and hedonic pricing sort of vicious circle that is at play here. But the upshot, of course, is that if you're going to clean up the environment, then you're going to primarily benefit the poorer people. That just follows from the structure of the initial pollution. The guy who did this was Ken Livingstone, who was the mayor before Boris Johnson was mayor of London, in case you forgot. He is not so popular now because he's a big friend of Hitler's, but he is also to the very left of the Labour Party, to the point that he is no longer a member of the Labour Party. And he did what you would expect from a left-wing politician. He actually, through this action, did not just clean up the environment in London, but also particularly helped the poorer Londoners over the richer Londoners, right? Livingstone is also the guy who introduced the bike sharing scheme into London, right? So, environmental pollution disproportionately harms the poor, and that then implies that environmental cleanup disproportionately helps the poor. It really then matters who carries the cost of environmental policy, right? And I think I've made this argument before. I'm sure I made this argument before, because so much of our environmental pollution is tied to energy. and so much of our environmental pollution is tied to agriculture, both of its food and energy are necessary goods. Poorer people pay a higher share of their income towards energy and food than do richer people. That if you make these things more expensive by imposing taxes, by having tradable permits, or by imposing environmental standards on these industries, you drive up the price of necessary goods, and that is necessarily going to hit the poorer harder than the richer, right? So yes, the benefits are greater for poorer people, but the costs may also be relatively greater for them. Which leaves me with 20 minutes, a bit more than planned. We're just going to end early, but I'm not before I make this particular point. Somewhere at the start of the lecture series, I told you that the environmental movement has its roots in Romanticism, right? Romanticism was a response against Enlightenment, with sort of harking back to the past and that sort of stuff. And out of that Romantic movement, three movements started. One was Nazism and nationalism, second was communism, and the third was environmentalism. And those three ideologies are siblings, essentially. And that means that deep in the roots of environmentalism, they share the racism of particularly nationalism, right? Environmentalism started as naturalism, and naturalism had very close ties with nationalism. And some of these roots were very, very explicit. The Worldwide Fund for Nature was started in the wake of decolonization, and the reason, the founding grounds for the Worldwide Fund for Nature, WWF, was that the European nobility feared losing access to the hunting grounds for big game in Africa. That is why Worldwide Fund for Nature was started by two guys, one who was actually a literal Nazi. He was a member of the Nazi party, and the other guy, other founder, was a member of the Afrikaner Broederbond. That is the organization that gave us apartheid in South Africa, right? These guys were openly, explicitly racist, right? Or perhaps in the first guy, well, worse than that. The second guy, well, pretty bad as well, right? So that is where the roots of the environmental movement are, and the environmental movement has not really shed those things. And the example that I'm going to give you is one that I came across recently. I should have been aware of this for longer, and that is the resistance to golden rice. So what is the problem? Around 250 million kids suffer vitamin A deficiency. That is, they do not eat enough green vegetables. And when your mother says you must eat your broccoli, she really meant it because it's good for you. And one of the things that green leafed vegetables bring you is vitamin A. And if you don't get vitamin A, you are prone to all sorts of infections. You risk going blind. And if deficiency is severe, then there's actually a pretty decent chance that you will die of this, right? So around 250 million kids per year suffer from vitamin A deficiency, and around 2.5 million die each year because of vitamin A deficiency. So this is a pretty big problem, right? And the solution, the problem is very simple. Their diet is so poor. A lot of this stuff happens in Africa, a lot of this stuff happens in Asia, and the problem is that they eat rice and only rice. particularly in places like India and the very poor parts of society, people eat rice, and that's the only thing they eat. And same is true for parts of Africa. So what people thought a solution would be is to put more vitamin A in rice. And through genetic modification, people actually succeeded in doing so by taking, there's actually two variants here. One, they took a gene from daffodils, of all things, and stuck it in rice. And another solution was to take a gene from maize and stick it into rice. And then that means that the rice plant and the rice seed, and that is of course what we eat, contains more beta carotene, and that is a precursor for vitamin A, right? So this solves the vitamin A deficiency problem in principle. You could still go with a diet that is only rice, but get enough vitamin A through that. Now, this has been on the market, or this has been available since 2004, that is 20 years ago. It has been declared safe for human consumption in 2018. It took their time, right? Because you also sort of like need to look at are there long-term effects of this, and they were a bit slow. But even though it has been approved for consumption in 2018, 6 years ago, it's still not on the market. And the reason for this is that the environmental movement is dead against anything that has to do with genetic modification. And in this case, it's actually daffodils aren't really scary, right? And using a gene from maize that is typically used for human consumption and stick it in rice, that doesn't strike me as something that is particularly scary, right? But the environmental movement is dead against this, has blocked this in Europe. It's declared safe in the United States. In Europe, you don't have a problem with vitamin A deficiency because your mother does tell you to eat your broccoli. But across Asia, across Africa, it's still forbidden in many places. And the main reason, the main organization that is behind this is Greenpeace. And it's not just that they've protested against this and written dubious scientific reports about this, but they also go and violently destroy test facilities and those sort of things. And this, I think, is entirely wrong. I understand that rich people in Europe are very picky about what they eat, and they sort of say, well, I don't want to run the risk of eating genetically modified food. That's perfectly fine if that is the preference that you want to express. If you can afford to eat organic food, perfectly fine with me, right? That is your choice. Do the white people in Europe who fund Greenpeace really have the right to say that Africans cannot eat golden rice? That people in the Philippines or people in India cannot eat golden rice? That strikes me as rich white people imposing their preferences on poor people in other parts of the world, right? Now, you may guess what my opinion about these things is. Of course, that does not mean that you have to agree with me. Going back to the very first lectures that we had, right? There's right and wrong in a moral sense. There's also correct and incorrect. You should have an opinion about these things, but you should not necessarily share my opinion about these things. I think this reveals the deep-seated racism that we see in the environmental movement. But that's my opinion. That's all for today. We have 10 minutes left. I'll give you that next week. We're gonna talk about environmental accounting. Okay, hope to see you guys then.